Hello again, people. We're back again to talk about transformations in geometry, and this time we're going to talk about reflection, the second type of transformation. All right, reflection is a mirror image across a mirror line. Just like when you look into a mirror, you see your image on the other side of the mirror. So for shapes, it's the same thing. A reflection is a mirror image across a mirror line, and the image is the same distance away from the object. Now, if we look at the point on each corner of the image, they are the same distance away from the mirror line in the opposite side. And the image that is created is congruent, but this time the orientation or the viewing angle is different. Just like your mirror image, when you look into the mirror, you look into the mirror, but your image looks back at you. So you and your image are facing the opposite directions or reversed orientation. So that is the same with shapes. So that's the same with shapes. Let's look at this example. Reflect triangle XYZ in the x-axis. So that means the x-axis is our mirror. There, the x-axis is the mirror, and on paper the mirror is indicated by this dashed line. Let's make it clear. So the x-axis is our mirror. Now, if you think about a normal mirror, the mirror is usually vertical. It's placed upright, maybe on a wall or something. So you stand on one side of the mirror and you look into the mirror and you see the image on the other side of the mirror. Now for this particular example, the mirror is the x-axis. So imagine that you remove the mirror from the wall and you put it flat on the floor, and maybe you want to suicide and you want to see how you will look in the mirror. So you hang two ropes on the roof, on the ceiling, one for your legs and one for your neck, and then you hang yourself out there in a horizontal position, and then you look down and you see your image on the other side of the mirror, which is on the floor. This picture sounds absurd, but I hope this is a good picture showing the mirror line as the x-axis. Okay, imagine that you are doing that. So your image will be below. You are up there, and since the mirror is lying flat on the ground, your image will be down below the floor or on the other side of the mirror. So that's the case here with this x-axis acting as the mirror line. So our object is above the x-axis, and so the image will be below the x-axis. Okay, like we did before in translation, you can trace out the shape, cut it out, and then you move it to the other side of the mirror. In order to do that, you have to first count how many steps away from the mirror the object is. You just focus on one point, maybe point X, and you'll see that it is 2 steps away or 2 units away from the mirror. So you move the object 2 steps down. 1, 2. Now, if you are tracing and moving it down, you have to keep in mind that a mirror image doesn't face the same way as the object, unlike this translation here. So you are going to like flip it over, and that's one more thing which is a little bit confusing when you deal with shapes. So to be on the safe side, you move point by point to the other side of the mirror. If you do that, you'll never go wrong. So let's do that. Let's move point by point to the other side, and let's start with point X. So point X is 2 steps away from the mirror. So the image will also be 2 steps or 2 units away from the mirror. So this is point X prime, the mirror image. Point Y is 5 steps away. 1, 2, 3, 4, 5 steps away from the mirror. So the image will also be 1, 2, 3, 4, 5 steps away from the mirror in a straight line. Okay, so we plot the point y prime, and we do the same for point z. So point z is 1, 2, 3, 4, 5 steps away from the mirror. And so the image of point Z will also be 1, 2, 3, 4, 5 steps away from the mirror in the opposite side of the mirror. And then we connect these 3 points, and here we are. This is the mirror image of triangle XYZ, and we call it triangle XYZ prime. Okay, let's study the coordinates of its point. If we look at point X, the coordinates are X is -4 and Y is +2. And for the X prime, X is -4 and Y is -2. Look at the X coordinates. They are exactly the same. The Y coordinates, however, the numbers are the same, but the sign changes. Okay, let's check another point. Point Y on the object as the coordinates as -4, 5. And the image point y prime is -4, -5. If you look at it again, the pattern repeats. We have -4, the x coordinate remains the same. For the y coordinate, the number remains, but the sign changes. So the thing here is, when we reflect the object along the x-axis, meaning the x-axis is the, okay, not along. When we reflect the image in the x-axis, meaning the x-axis is like our mirror, then the image is only moved down to the other side. If the object was up there before, the image will be now below. So we are moving down from the object. If the object was below the mirror before, then the image will be up there. For both cases, we are moving down and up, not left or right, just down and up. So the x-axis remains the same, but it's only the y that is changing. Before it was positive y, now it's negative y. Or if the object was below, then before it was negative y, and as it moved up over the x-axis, the y changes to, before it was negative y, and as it moves up, the y changes to positive. Okay, if the mirror line was the y-axis, let's use a different color. If the mirror line was the y-axis, oopsie daisy, my line is not straight. Okay, let's try again. If the mirror was the y-axis and the object was on the left-hand side, then the image will be on the right-hand side, the opposite side of the mirror. That means we are going from the negative part of the x-axis to the positive part of the x-axis. The y, however, remains the same because we are moving in a straight line across. So if our mirror line is the y-axis, then the y-coordinates remain the same, but the x-coordinates will change from negative to positive or from positive to negative. It depends on where the object is before it is reflected. And so here are these two points to take note of. And take note, this only applies to cases where the mirrors are the x-axis and the y-axis. So the 2 points to take note of, the signs of the y-coordinates change for reflections over the x-axis. That means when the x-axis is the mirror, then only the y-coordinates will change, but the x-coordinates remain the same. Now when the mirror is the y-axis, then we'll be moving left and right, so the x-coordinates of the points will change. Okay, I hope you got it, so let's go and check out some practice questions. Right, let's see this question B here. Draw the shapes in your book and reflect them in the mirror lines provided. Let's try with the first one. Or let's try this one where the mirror line is a slopey one. Okay, take note. Your image, when you look into the mirror, will be exactly on the other side of the mirror line, meaning it will form, you will form a 90-degree angle with the mirror, and your image will also form a 90-degree angle with the mirror. If you stand on the left side of the mirror, your image won't appear on the right side of the mirror in the other side. Your image will also appear on the left side. Or if you stand on the right side of the mirror, then your image will appear exactly on the right side as well. It won't appear on the left side. So you and your image are forming right angle with the mirror line. Keep that in mind when you are reflecting your points and the shape in the mirror. So let's start.
All right, for this second shape where we have to reflect in this mirror line which is slopey, you see the image must be the same distance away since we cannot get exact squares for the points here. See, there's a little bit of distance here which we cannot estimate on the other side. We have to use a paper to exactly measure. So here's a get a clean piece of paper with a smooth edge and you measure the distance. Now take note, the object and the image must form 90-degree angle with the must form a 90-degree angle with the mirror line. So Here's the mirror line. The mirror line comes down this way. The image and the mirror line must form a 90-degree angle, and that's where you move your image to the other side. So let's measure and mark. Okay, here marks the mirror line, and this is the first point. Let's call it point P. Okay, the same distance is gonna be measured on the other side in a straight line perpendicular to the mirror line, and we mark point P on the other side. So this is P prime. Then we do the same to this other point. Let's call it point Q. So again, make sure your paper must be perpendicular to the mirror line to the point. So mark point Q, and the same distance must be measured on the other side in a straight line. So we mark it there, and that's point Q prime. Then we do the same to the third point, and let's call it point R. So again, from the mirror line, we mark out point R, and we measure the same distance on a straight line on the other side of the mirror, perpendicular to the mirror line. And here is point R prime. Yes, point R prime. And when we connect those 3 points together, voila, we have the mirror image of the triangle PQR. Mine may not be exact, but you get the idea, right? Okay, so now you are going to do this tree here as practice on rotation.
Just take a snapshot and put it in the comment section below so I can have a look at your answers. And this is it for reflection. Stand by for the next one on rotations. Like, please, and subscribe to the channel. Press the notification bell so you don't miss out any of the videos that are coming up. May I remind you again, I'll be uploading videos after videos which relate to revision questions before the exam. So stay tuned. See ya. So your image is a flip